All right, everyone, welcome back to another science lesson with Miss Rachel. Okay, today we are going to be covering how to calculate our electrical use. So, first of all, as always, please put your name and date on the top and underline that I can statement. The I can statement today, I can determine the energy used by a device using its watts. So, first thing, what are watts? Wattage, what is it? Now, we actually covered this in a Bill Nye video, but watts is basically the amount of energy a device needs to work. That's basically what a wattage is. So I'm going to write that down for you, okay? You can write along with me. Let's not use yellow. Okay. It is the number, oh my goodness, number of watts of electricity that a device needs in order to work. Whoops, went off the line there a bit. So basically, watts is the energy that a device needs in order to work. Okay, what is a kilowatt? So it's kind of like grams and kilograms. It's the same premise. So a watt is like 1 unit, and a kilowatt is 1,000 watts. So you write 1,000 watts. Kilometers, meters. Kilowatts, watts. It's basically just the bigger measurement of watts. Okay? And what is a kilowatt per hour? So, this is a measurement that tells us, oh my goodness, tells us how many kilowatts were used in an hour. So basically to figure out how, So basically to figure out how much energy a device is using, all we need to do is know its watts and then how long we were using that device for, and then we can actually figure out how much energy we used, how much real energy, which is actually really, really cool. Because any device you have in your house now, kettle, light bulb, hair straightener, hair dryer, whatever, all you need to do is know the wattage and plug in how long you used it for, say 20 minutes, and you'll know actually how much energy you used. You can do this with your Nintendo Switch, you can do it with a PlayStation, you can do it with really any electrical device, which is actually super cool. So, basically we're looking at this box here right now. So I want to know, how do we calculate this? How do we know how to figure this out? So, we have the wattage, which is always listed on the bottom of any electrical device, which I'll show you guys in a second. Kilowatts is watts divided by 1,000. So basically this column here, all we're doing, it's kind of like in patterns and relations. You guys remember the input-output boxes? All you're doing to get from this box to this box is dividing by 1,000. Okay? And we're not expecting you to do that by hand. You can absolutely use a calculator for this. Okay, to get the energy used column, all we have to do is number of kilowatts times the number of hours. So basically, to get this column, all we have to do is multiply this number by this number, which will equal this. Okay, does that kind of make sense? This column times this column equals the amount of energy we used. And we can do this again with any device in our house that lists the watts. And you can look on the bottom of a kettle, even a microwave. Every appliance that you have will have the wattage listed on the bottom, which is really cool. So now, I'm going to try and show you. Here we go. So it's kind of a blurry picture, but if I can just write on it here, I can show you. So it's got all this information, where it was made, what type it is, the voltage, the hertz, and here we've got the watts. So this is actually the bottom of the kettle that I've pulled up on Google, and it will say 1500 watts. So really, you can find this on any electrical device that you have at your house, okay? So let's go back to the document, and let's try the first one together. So, scrolling down, we've got the kettle. So make sure you've got a calculator handy, or if you're really good at dividing by 1,000, then absolutely you can do mental math, but dividing by 1,000 is a bit of a challenge. Let's do purple this time. So remember, to get to this column, all I want to do is divide by 1,000. So let's plug it into our calculator. 1,500 divided by 1,000. The cool thing about dividing by 1,000, for those of you who are a bit of a math whiz, all you have to do is move the decimal place 3 points. 1, 2, 3. Which would actually end up being 1.5. Okay, let's do it for the next column. Let's do all the first math first, and then we'll move on. So this is, again, divided by 1,000. 15 divided by 1,000. So you can either move the decimal place or plug it into your calculator, and you will hopefully get this answer. Okay, let's move on to the next one. We want to know how many kilowatts a microwave is. All we have to do to get kilowatts from watts is divide by 1,000. 1450 divided by 1,000 equals 1.45. Okay, I want you to try a couple yourself. Pause the video now, complete the column, and when you are finished, hit unpause, and I'll go through the answers with you for this column only. Okay, hopefully you just hit play again, and we're continuing on with checking our answers. So, 1,000 divided by 1,000 is 1. All right, moving on again. We're just dividing by 1,000 again, the next column. 6 divided by 1,000 is 0.006. Again, we're just moving the decimal point, just like we did in our place value unit. And last one, 240 divided by 1,000 should equal 0.24. Great. So we've got our watts that were already given to us. We went into our own houses, let's pretend, and we found the wattage on each device. Now, not all kettles are 1,500 watts, but the one that I found was. Okay, so check your own kettle at home. Check different light bulbs. There's different wattages of light bulbs. There's different powers of microwaves. So check on your own devices at home to find out more interesting stuff about wattages. Okay, so we have the watts. We have the kilowatts. We don't need the watts anymore. Basically, we were just using that to figure out the kilowatts. Now, my end goal is to figure out how much energy I used in these appliances, okay? So, if you remember, all I'm doing to calculate the energy is this column times this column equals this column. So, my kettle is 1.5 kilowatts, and I used it for half an hour. So how much energy did I use? So grab that calculator, 1.5 times 0.5 equals 0.75 kilowatts per hour. Okay, great. Let's continue. We're on light bulb, 0.015 times 6. Okay, 0.09 kilowatts per Remember, I just did this times this equals this. Okay, keep going. Hopefully you got this answer. Cross your fingers, I hope you did. Okay, pause the video here and complete the last three, and then once you've completed them, unpause and let's go through them together. All right, welcome back everyone. Let's stay on blue. I hope you paused it, you've calculated your answers, and now you're ready to keep going. So again, I'm just to figure out my energy used column. All I'm doing is multiplying my kilowatts by the total amount that I used it. Okay, so let's keep going. 1 times 1.5 equals, of course, 1.5. We don't even need a calculator for that because we know 1 times anything is that anything number. Next column, we've got the clock radios, which is basically like an alarm clock. In the days before we used our phones for an alarm, maybe your parents still have an alarm clock beside the bed, who knows? This should equal 0.144. Give yourself a pat on the back if you got it. And the last one, 0.24 times 24 hours. Because these ones are always on, 24 hours a day basically. You never want to turn off your fridge because, well, as you know, then your food wouldn't be cold and things would be rotten. So appliances like fridges, radios are on all the time, but microwaves are only on really when you need them. Light bulbs are also on for a lot of the time unless you turn off the lights when you leave the house. So here are our answers. Please cross-reference. Maybe give yourself some little tick marks. We did the first few together, but definitely check those last few, and let's move on. Alrighty, so according to all of that work that we just did, which device has the highest wattage? Now I'm just going to pause here for a few seconds and you guys can decide which had the highest wattage. Okay, hopefully that was enough of a pause. And remember, this question says highest wattage, not which one used the most energy. So the one that in the column, the device's wattage, which one had the highest wattage? And it actually was the microwave. It didn't say which used the most energy. It said which one has the highest wattage, which one takes the most amount of work to actually power the machine or the appliance, okay? On the other hand, which device has the lowest wattage? So don't look at the energy used column, just look at the wattage column. Which one had the absolute lowest? Pause here for a second. Okay, hopefully you've determined that the clock radio, alarm clock, had the lowest wattage. Okay. So this is more of a thinking question, so I'm going to ask you again to pause after I read this one, but I want you to think about, why does something like a microwave have such a higher wattage than something just like an alarm clock or even a light bulb? Why do you think a microwave has so many more watts than a light bulb or an alarm clock? What do you think? Pause here and give me your best answer. If you'd like to add on the ultimate answer afterwards, that's awesome. You've got some space down here that you can do some writing as well, right? Okay, hopefully by now you've unpaused, but you've taken a second to write the real answer. I trust you. So basically, things have different wattages, especially microwaves and stuff, because they have two jobs. They've got to use heat energy, they have movement energy. They're basically putting in way more work. All a clock radio has to do is have enough energy to light up a tiny little red number, basically. But a microwave has got to do tons of heat, it's got a movement, it's got timers, it's got so many jobs inside of it that have to be powered by electricity. So basically, things that heat things as well have way more wattage than things that just kind of light up a simple screen. So the easy answer is that whoops, get that pen out, proper color. Wattage, oh my goodness, wattage is different for different purposes. So again, I'm going to need way more watts if I need something to heat up or even cool something than I am just to light up a small screen or light up a little light bulb. If I suddenly have to, even like an iron, if I have to make it hot, I need something to power the steam, then it's going to have to be a higher wattage than just a simple clock radio. Okay, and I'd also like you to write devices that heat things, like I said, and even cool things, but more heat things. Devices that heat things require way more wattage than other devices. And like I said, on the clock radio, the only reason it didn't need so much is because really its only purpose is to keep the time and display it on a little screen, right? It doesn't have to put all that energy into actually heating up food and do all that extra work, okay? So something else to reflect on after this lab. So basically we've discovered what watts are, and it's energy used by electrical appliances. But we know that we like to look at the kilowatts, which is divided by 1,000. And then in order to find out how much energy is used by an appliance, all you do is do the kilowatts times the amount of hours or half hours that it was used, and you can find out how much energy was actually used. And the purpose for this is when someday you have your own home, or even in your home now with your parents, you can calculate, okay, so our fridge is using up, let's say, what was our fridge using up? 5.76 kilowatts. So that's not too bad because we need our fridge. But you could say to mom and dad, our light bulbs are wasting, let's say, I mean, ours is only doing 0.9 kilowatts per hour. What if you had your lights on all day? What if you sleep with the light on at nighttime? Think of how many more watts and how much more energy that's using. So if you could calculate that and say, hey, we're actually using 10 kilowatts for our light bulbs in all of the house, maybe we could try and cut that in half. Because your parents, I know you don't, but your parents have to pay for electricity, and also electricity is energy. And we want to save energy, right? Because if we turn off the lights and we conserve energy, that's less stress on our climate as well. So the purpose of knowing how much energy an appliance uses is really helpful in your own life, in your parents' life, in the future. Okay? So I hope you guys learned something today about wattage and energy used. If you have any questions, as usual, please message me, Mr. Matt or Miss Mavish on Edmodo, and I will see you next time.